When my quadratic function is given to me in standard form, there's some work I need to do in order to find the line of symmetry and the vertex. As a review, when I'm given the function in vertex form, I can just look at it and identify immediately the vertex and line of symmetry, but I need to do some work in order to find the y-intercept. So from vertex form, I need to convert to standard form, and then I can see the y-intercept. When I'm directly given the function in standard form, I can immediately identify the y-intercept. So there's no work that needs to be done if I'm given the function in standard form in order to find the y-intercept. I just write 0, c. The work that has to be done is finding the line of symmetry and the vertex. The line of symmetry is found by using my b and my a values from my standard form. The line of symmetry is found by taking the opposite of b, or b times -1, divided by 2a. In this example, a equals 1, visible 1 here, b equals -4. The c value does not matter for the line of symmetry. To find the line of symmetry, I take the opposite of -4. I don't have to show that work. I could just think, oh, the opposite of -4 is +4. And then I divide that +4 by 2 times a, or 2 times 1. So opposite of b is 4 divided by 2a divided by 2. 4 divided by 2 is 2. So my line of symmetry is x equals 2. I can see that here. This is the graph of the function x squared minus 4x plus 1. The line of symmetry divides the parabola into two symmetric halves and is given by the equation of this vertical line, x equals 2. For this example, a equals 2, b equals 8. So my line of symmetry is given by opposite of b, -8, over 2a, 2 times 2. -8 divided by 4. Line of symmetry is just x equals -2. Please be really careful to include that x equals part and not just write -2. The line of symmetry is the equation of a line and needs to be in the form of the equation of a line. Opposite of b over 2a here, we have a equal to an invisible -1, b equal to 6. Opposite of 6 over 2 times -1, -6 over -2 would be +3. The line of symmetry is x equals 3. Now, the vertex always goes through the line of symmetry. If we look at the same graph, wow, not straight. My line of symmetry, x equals 2, my vertex by definition always, or my line of symmetry by definition always goes through the vertex. The x coordinate of my vertex is found by the x value in my line of symmetry. So since I have found for this function that the line of symmetry is x equals 2, I know that the x coordinate of my vertex is 2. To find the entire vertex, I just need to find the y value of my vertex, or f of 2. That means evaluating the function for x equals 2. F of 2 in this case is just 2 squared minus 4 times 2 plus 1. 4 minus 8 plus 1. This is where students tend to make a mistake. They add for some reason first. Don't do that. 4 minus 8 is -4 plus 1 is -3. So finding f of 2, or just plugging 2 in for x into my function, gives me the y coordinate of my vertex. The vertex of the function x squared minus 4x plus 1 is x equals 2, y equals -3. Again, the way that I found that was I first found opposite of b over 2a, my line of symmetry. I had already done that on this page. And then I plugged that x value into my function. For these two, since I only have this much space, luckily I already found my line of symmetry. So that is the first step. If you're given a function rule, you first find the line of symmetry. That is equivalent to finding the x value of the vertex. So I found that here. The x value of the vertex is -2. To find the coordinate of the vertex, I need to find f of -2, which is just plugging in -2 for x. So order of operations, 2 times 4 minus 16 plus 5, 8 minus 16 plus 5, which is negative 8 plus 5. And that's weird. Once again, I got negative 3. So my vertex is x equals negative 2, y equals negative 3. Again, if I had not already done the work on this page, finding the vertex would be a two-step process. I would first find opposite of b over 2a. That would give me the x value. And then I plug that x value into the function rule. Here, I found that the line of symmetry is x equals 3. So to find the y value, I just need to find f of 3 or evaluate the function for x equals 3. Order of operations square, and then multiply by negative 1. My y value of my vertex is positive 6.